When any chemical reaction occurs, energy is transferred either to or from the surroundings, which means it's either given out or taken in. This is due to bonds being broken and formed. So if we take the example of hydrogen and oxygen reacting together, when you have hydrogen and oxygen in the air, if they bump into each other, nothing happens. They haven't got enough energy to react. So what you have to do is you have to put in the energy. So you usually get a match. In other words, energy must be supplied to break the bonds that are already there. This is an endothermic reaction. Once all of the bonds are broken, new bonds start to form. This process gives out energy, which is called an exothermic process. So in this example, oxygen reacts with hydrogen to form H2O, water. So you put energy in, which is endothermic, to break the bonds. And when new bonds are formed, energy is given out, which is exothermic.
There are two different types of energy changes when a chemical reaction occurs. One of them is exothermic and one of them is endothermic. In an exothermic reaction, heat is given out, which means the temperature goes up. In endothermic, the heat is taken in and the temperature goes down. In order to test this, you need to use either a thermometer, a normal one, or a digital thermometer. It's a lot more accurate. You can see it goes down to 1 decimal place. So you can pop this into the liquid and have a look at what happens to the temperature. To start the reaction, add in your other reactant. So in this case, I'm adding hydrochloric acid into sodium hydroxide. In here, you can see the temperature will start to rise. As you can see, the temperature has gone up from about 19.7 to 24.7. Temperature's gone up, heat has been given out, it's exothermic. You can see here the temperature is going down, therefore this is an endothermic reaction. The biggest problem with any temperature measurement is the fact that heat gets lost to the surroundings, so heat will be given out through the beaker to the surroundings. To get by this, what you can do is use a polystyrene cup and put cotton wool around the outside. This acts as an insulator and keeps the heat inside the cup. So start by putting reactant A in, put the lid on and take your starting temperature using your digital thermometer. Remembering that a digital thermometer is a lot more accurate than a normal thermometer. So the copper sulfate starting temperature is 20.2. So record that and then put in your reactant B, which in this case is iron filings. Put the lid on, add a bit more cotton wool over the top just to prevent heat loss, and then have a look at what happens to the temperature. So what type of reaction is this? Endothermic or exothermic? The answer you should have got is exothermic.
You need to be able to draw energy diagrams to show both endothermic and exothermic reactions. We start off with our reactants, hydrogen and oxygen. What you have to do is add energy to break those bonds. The amount of energy that you need to put in to break those bonds is called the activation energy, the energy required to break the bonds and to start the reaction occurring. Once the bonds are broken, energy is given out. Now, depending on whether it's exothermic or endothermic, you'll end up either with a line here or here. For an exothermic reaction, the line will be down here. And these are your products. The change in energy here shows that energy from the reactants has been given out to the surroundings, so the product ends up with less energy. The energy has exited, it's gone out, and there is less energy within the product. In an endothermic example, again, you have to put in energy to break up the products. This is called the activation energy. However, this time, the energy of the product is greater than the energy of the reactant. Energy has been taken in from the surroundings, which is this amount here. Therefore, it is endothermic. So, which of these two is exothermic? A or B? You have 5 seconds to decide. 5, 4, 3, 2, 1. So A was exothermic and B was endothermic. You will be asked to draw these in the exam, certainly in the higher paper, so make sure you learn them. Key things to remember from this are: for exothermic, the reactants have more energy than the products. Energy is therefore given out to the surroundings. It exits, which makes it exothermic. In endothermic, reactants have less energy than the products. Energy is taken in, it enters, which makes it endothermic.